So what we are going to do today is we are going to create a new notebook, and that will be for hierarchical clustering. Okay, so this is our notebook for today. So what we will do first is borrow some codes from yesterday's class. So that's the code for importing libraries, right? So that's the first code. Then the second code is for loading the data. So those are the two things we will borrow from yesterday's code notebook. So as you are copying that, let's discuss some few things that we see here on hierarchical clustering. So hierarchical clustering is a type of clustering algorithms that groups similar data points into groups or clusters. So it is based on a tree-like structure called a dendrogram. So if we Google that, so this is what a dendrogram looks like. So it's like a tree whereby, so let me open this image in a new tab. So this is a tree whereby we have the tree height and we have some outputs here. So when creating hierarchical clustering models, you can create these models starting from the top up here, that is making splits from the top, or you can start from the bottom, so from each individual item here and combining them. So what you can see here is there are two types of hierarchical clustering. So one is the agglomerative clustering method. So this method starts with the individual data points as separated clusters and iteratively merges them into one larger cluster. So I can demonstrate these practically and you can see how that works. So the first one we've said it's agglomerative. So we start from the bottom going to the top. So this is what we will have. So this is the agglomerative way, and this is the other one, which is divisive. So how do we create the agglomerative one? So we start from the bottom. So let's say we have X, Y, Z, and W. So this is what we will have. So for example, X and Y have similar characteristics, then Z and W have similar characteristics. Then what we will do is, so let me make it even more a little bit complicated. So let's say we have something like that. So we can say X and Z are similar. Then we have X and W which are not similar. Then what we can do is we can combine these two, and then we can combine that to come up with one big class. So we are starting from the bottom going up. Then for this other one where we have X, Y, Z, and W, so the divisive method, we start from the top. So after starting from the top, we have that first split. Then we have this second split here. So this goes down to W, then we have the last split there. So that's how divisive works. So starting from the top, going to the bottom. So let's read it more. So we have the agglomerative. So this is the method that starts with individual data points as separate clusters and iteratively merges them into larger clusters. Then we have divisive. So this is the method that starts with all data points in one cluster and iteratively divides them into smaller clusters. So here we have some Python code to do this. Yeah, so we have the Python code to do the plot and we have the one to feed the data. So what I'll do is I'll copy this one for doing the plot and we can import it here. So from sklearn.cluster import agglomerative clustering. Then I can remove this because already we have the iris dataset. So what we will do is for this part where we have the iris dataset, so what I'll do is I'll copy this part here from the k-means part. So don't worry, I'm sharing this data with you. So we have k-means data and we will feed the k-means data here. So here I'll change this. Instead of k-means, we will have HC. And then I'll change this to HC. So yeah, then we are going to create our Y labels. So which is our generated labels should be equal to that. Then what I'm going to do is I'm also going to copy the code for doing the plot and we can compare our plot today with what we had yesterday. So let me change a few things here. So just borrowing some few stuff from the code we had yesterday. Okay, so that's what we have. Let me share that code in the chat and then we can proceed. Yeah, so the code should be okay. So what we do first is from sklearn.cluster, we import agglomerative clustering. Then after importing agglomerative clustering, we load the iris dataset. So here where we have Y labels, so delete the dot labels part. Then after importing the agglomerative clustering model, we define our HC data. So we drop the species column because we don't really need this column. Then we instantiate our model. So AG clustering. So this is the agglomerative clustering and specify the number of clusters to be equal to 3, corresponding to the 3 unique species we have in our data. Then we have our Y label, which should be equal to agglomerative clustering, so the variable we created here. Then we get the labels. Then we can plot and confirm if the plot we are getting is somehow similar to what we had yesterday. So if you check this plot, you can see we have the 3 distinct groups. So these 3 distinct groups are similar or close to being similar to what we had yesterday. So if we compare hierarchical clustering to k-means, you can see, so on the left hand side, I have my k-means plot. On the right hand side, I have my hierarchical clustering plot. So if we do a comparison of the two models, you can see they work in a similar way, giving us similar results. So when fitting either hierarchical or k-means model, you can pick either of the two. So basically that's how we do it on hierarchical clustering. Any questions on fitting hierarchical clustering models? Yeah. So the next thing we will do is do the plot for hierarchical clustering model. So we have the code here for that. Then I'll have to explain to you what each and everything we have here is all about. So I've copied the code from our notes and I'm going to remove some few things because already we've imported the data and we will just be left here with some of the most important things that we need. Okay, so what we have here is just this single part here where we are going to, so we are going to use a library called scipy, then cluster.hierarchy to plot our dendrogram. So we have something that is known as linkage, and we have the dendrogram plot part that allows you to plot the dendrogram. So what is linkage? So if we go to our notes, so let me share this code with you first in the chat, and then we can discuss what is there in the notes. Yeah, so you can copy that code. So let's discuss first what's in the notes and then we can do the code. Okay, so here in this code, we have the part where we are fitting the model, but the first thing we need to do is we need to compute. So after fitting the model and getting, so after fitting the model here and getting a plot showing us the three distinct features that have been created, so the next thing we usually need to do is we need to plot the dendrogram. So to plot the dendrogram, we import linkage and dendrogram from scipy. So these are the two libraries that will allow us to plot the actual thing that we need. So what is this linkage part here? So if we go to our explanation, you can see linkage. So the linkage matrix represents cluster and the columns represents the linkage criterion. So instead of us going through the notes, let's research this online. What is a linkage matrix? And we are going to check the scipy documentation. I'm going to find and then I'm going to search for linkage. So here you can see some calculations. Let's see if we can get an explanation. So linkage methods are used to compute distance between two clusters. The algorithm begins with a forest of clusters that have yet to be used in the hierarchy being formed. So when two clusters, for example S and T, from this forest are combined into cluster U, S, and T are removed from the forest and U is added to the forest. When only one cluster remains in the forest, the algorithm stops and this cluster becomes the root. So linkage is used to join. So if we go back to this image that we had here, so linkage is used to join the small trees that we have here to the main tree, so that, for example, we can have the bigger tree here, so the upper part being linked to these small parts until we can't create any further extracts from the data. So what I can do here is actually I can say something like, document what is happening here. And then we are going to see a response of what is happening there. So as that is happening, let's go back to our notes and see. So there are different linkage criterions that we can do. So the first linkage method we can use is the word method, so which minimizes the variance of the distances to the linkage. Then we have single, minimizes the distance between all data points of the two clusters. Then we have complete, maximizes the distance between all the data points of the two clusters. Then we have average. So average takes the average of the distance between all data points to the two clusters. So the linkage matrix has a size of n minus 1 multiplied by 4, where n is the number of data points Then the first two columns of the linkage matrix represent the two clusters that are merged in that row. And the last two columns represent the linkage criterion value and the number of original observations in the new cluster. So these should be the X4 part. So in the example that we have in class, the linkage function used for the iris dataset is the word linkage criterion. So the linkage matrix Z is then passed to the dendrogram function. So this is the dendrogram function that we have over here, which goes ahead and plots what we need to see. So let's stop this and run our code cell and see if we are going to get the dendrogram. So this is what we have. So you can see it's a tree-like structure. So similar to what we have in decision trees. So it's a tree-like structure. So what we can say here is in supervised learning, we have tree-based model and then non-tree-based models. So decision trees and random forests are the tree-based models. Then the other ones are the ones that use distance. Okay. And same for unsupervised models. So we have tree-based models, so which is the hierarchical clustering model. And we have the non-tree based models, which are the k-means, which use distance. Okay. So let's see this part here being explained. So we should get an explanation here. So here you can see the linkage function in Python module is used to perform hierarchical clustering on a dataset. So the function takes two arguments, the data to be clustered and the method to be used in clustering. So in this case, the C data variable is the data to be clustered and word is the method used for clustering. The word method is a hierarchical clustering method that minimizes the variance of the distance between the clusters being merged. So this is one of the most commonly used method for hierarchical clustering. The output of the linkage function is the matrix that represents the hierarchical clustering of the data. Each row of the matrix represents a merge between two clusters, and the columns represent the indices of the clusters being merged and the distance between them. The resulting matrix can be visualized as a dendrogram using the dendrogram function. So that's basically it. So let me insert this into our notebook for today's class as text, and then you'll get the explanation there. And what I can do is I can also add an explanation to what is hierarchical clustering. But I guess there is no need. So hierarchical clustering is that simple. So I will wish to stop there, not unless you guys have questions concerning what we've looked at. So based on this part and this part, but I think this part you've already understood because we literally follow the same steps. So preparing our data, importing model and instantiating model, then fitting model to data, then extracting labels. So for unsupervised learning models, we are just extracting labels. Okay. Any questions? Yes, Samuel.
Good afternoon, good evening. I'm
Yes,
trying
good
to
evening.
catch up.
Yeah,
I joined in late and I think I've missed one class. I'll go through the recordings, but I'm trying to understand on this class.
yeah,
I the tree and the hierarchy. Yeah,
yeah,
you're seeing the decision tree. Okay,
yes,
so if you are to explain this, I know you've explained like in a nutshell, because
yeah,
I'm trying to get my thoughts together so that I can understand if I are to explain this.
yeah.
How would you explain it? What have we done exactly? Like to not in a technical way, like the way we are doing, like to a person who we are trying to present it to.
So maybe I'm trying to explain this in a simple way, right?
Yes, especially people who don't need to know the
The
process,
practical
the
part. Okay. Yeah,
whatever we've done. Yeah.
yeah. So what I will say is, let me pick a bank scenario, right? So I'm trying to delete a few things here. So in a bank scenario, let's say we have individual A and we have individual B, right? So for individual A, let's say he has a salary of 100K. His age is 40 and the deposit he made to our bank account is, let's say, he made a 1 million deposit into our account. Then we have individual B whose salary is, let's say, 10,000. Then the age of this individual is, let's say, let's say 18. So this guy is 18. Then the deposit this guy made is 1.5 million into our bank account. So if you are working as a data scientist, so what you are trying to do is group these transactions into either suspected fraudulent activity or not. So what we will do first of all is, so for me, I'll use the first method, which is the agglomerative method to define if a person is performing a fraudulent transaction or not. So here for fraud, and we can say none fraudulent. So we have these individuals. So what's the age? So we will start from the bottom. So this is non-fraudulent and fraudulent activity. So for example, what's the age of this guy? So if the age is less than 20, for example, but I should not start with the age. So I should basically start with the deposit. So the deposit here is, let's say, greater than 500,000. Okay. So the deposit there was greater than 500,000. Then the deposit here should be less than 500,000. So this is an unfraudulent activity. So we go up here to the deposit part. After going up to the deposit part, we again split this into something else. So what's the age of these guys? So we can have something like the age of this person. Okay. So this can go down here to the non-fraudulent directly, and it can go down here. So we can say this guy is greater than 25 years. Then this one is less than 20, for example. So what we are actually doing is we are going through each and every characteristics that is in here. And chances are, in the end, we are going to have a tree that looks like this. So for example, we can start with age. So here less than, so that's the less than sign, less than 20, then greater than 20. So if we check that again, we check for salary. So less than 100,000, greater than 100,000. Okay. After checking the salary again, we come up with something like the deposit. So greater than, so not greater than, but less than 1M, greater than 1M. And we can conclude that this is not fraudulent. And here we can conclude that this is fraudulent. Then we can do the same for the guy with an age of greater than 20. So what we are actually doing here is coming up with different outputs based on the characteristics that we have for this guy. So you can see, for example, for guy B, we will say that this is a fraudulent transaction because this guy is young and the amount of money he's depositing is quite huge based on his salary here. So he should not be depositing such huge amounts of money. So does that answer your question concerning the hierarchical clustering and maybe what we are trying to do?
Yeah, I think I've gotten the gist of it, as
Yeah,
in from the outcome. Yeah,
yeah,
which makes a lot of sense.
yeah. So maybe I
Yeah,
can quickly share a second example with you. Is that okay?
please, yes, yes.
So yeah, a second example will be in terms of sales, right? If you are a person working in the sales industry, and we can pick an example of the Naivas supermarket. So in the Naivas supermarket, let's say we want to have a promotion. So, and for this promotion to happen, we need to share it with the customers that we expect to like participate more in the promotion. So for us to do this, we will get the transactions performed by a customer on a monthly basis, then the amount of money spent. After getting the amount of money spent, we will check the items these customer purchases most of the time. So what we will do is we will create something like this circle. And inside this circle, we will have different groups of people. So we have this group of individuals. Let's say that's group one. We have group two here. And we have group three there. So what we are actually going to see here is that we have group one, group two, and group three. So our model will be able to group and say that these are good customers, and based on their characteristics, they make purchases often. Okay. Then we can say that these are mid-performing customers. So they usually come to shop with us regularly, but not that much. Then these are worse performing customers. Okay. So maybe one transaction. So if you were to run a promotion, then you can run a promotion that's different for these guys, another one that's different for these guys, and another one that's different for these guys. So your target will be to cater for the needs of each and every individual. So these guys might have a loyalty card with the supermarket, so you can run a different promotion for these guys. So how will you identify these guys? Right? So you don't have labels that tell you that this is a good customer. So what hierarchical clustering does and the K-means model does is it groups your customers into these different groups. And with the groupings that you have here, you'll be able to know that these are my good customers from the model output. These are my worst customers and these are my mid performing customers. So hope that explains fully what unsupervised learning is used for. So it's basically used for data grouping, whereby you can have different parts of the data with different characteristics. Is that okay?
Yeah, these are perfect. I mean, an example.
Yeah,
Now, I think also, like, when we go back to our model,
yeah,
I'm trying to connect both. I think that's where I have my disconnect between just down there, the tree, the hierarchy.
yeah, this one here.
So, yeah, yes, and I understand how you explain it. Now I'm trying to connect. So, like this one, based on the data that we have used,
Yeah,
I'm trying to understand the outcome exactly. And I mean, going on the way you given two examples.
yeah,
So, like, I'm trying to figure because this is more of a graph
yeah, this is more of a graph.
other but where is how can I get like the cluster of the good performing, worst performing, and mid performing? Is there a way, or we've not reached there, or a way to get that data based on the data we have?
There is a way. So these labels part here. So do you see
Yeah.
this part where I've extracted the labels? So so you have to extract this part here. And after extracting the labels, so what do you do? So after extracting the labels, what you would have to do is group the data in terms of the label and do some EDA. So using your EDA, you'd be able to now understand the characteristics of each and every distinct group that has been created. So what the model does is it splits your data into the three distinct groups. But on your end, what you'd have to do is go ahead and perform some extra EDA stuff to get to fully know what are the different characteristics that are in each distinct group that we have in the data. Is that fine? Or have you?
Yeah, yeah, yeah. No, that's fine.
Yeah. So you'd have to create a new column in your data called maybe like say for example the species column. So in this case we are assuming the species column is not present. And what you'd do is once you've gotten your labels, you'd create your new species column and now analyze the different characteristics that we have for each distinct species so that you would know that this is the average spending for this group, this is the average size for this group, this is the average salary for this group. So things like that will allow you to come up with decisions as to what you need to do next.
Okay, noted, Joseph. I'll
Okay.
request maybe, if possible, we can use more practical
Data sets.
data,
So yeah, so maybe
data set, one that we can relate to, so that, because like this one is very hard to
to
relate
understand.
to, yeah, and to understand, especially when you're learning. But I got it. I've got it well explained.
Okay, so
Thank you.
what we will do tomorrow is yeah, so instead of us looking at our new concepts, so tomorrow we will feed a hierarchical clustering model or maybe a K-means model. And after doing that, we will perform some EDA. So I'll try find some sales data. After getting the sales data, we will cluster the data into, let's say, 4 or 3 clusters. Then after doing the 4 or 3 clusters, we will try do some EDA on that data and see what are the different characteristics that we have for each distinct groups. So is that okay? So that will be a practical session.
Yeah, that's fine. Thank you.
Okay, okay. Yeah, any other question? Okay, so if you have no other questions, I think we can end the session there. So let me upload the